Send that paper to the corner. I hope you have written all name, index number and the class. Collect the papers to the corners and it's easy for me. Collect them to the corners. So we were in the process of doing usages of dimensions. I have given few questions or few formulas to evaluate dimensions. Now let me to finish those first. What is the very first equation I have given you? F equal HF. That I did here or not done? Equal HF not done. Right. So give me one by one, I will be doing and discussing. So you can check your one. If it is done properly, you can take it. First, E equal HF. E energy. Energy. Dimension of E. Dimension of E. Tell me, son. M L squared T minus 2. Frequency F. Frequency dimensions T minus 1. In this process, what you do? You subject this. Subject H. E divide by F. Dimensions of H is equal to dimensions of E divide by dimensions of, or by E divide by F dimensions. This is equal dimensions of E divide by dimensions of F. Now E dimensions you can copy from there. ML squared T minus 2. F T minus 1. T minus 1 and T minus 2 cancels off. Only 1 T minus 1 will remain. ML squared T minus 1 will be the dimension of Planck constant H. H is Planck constant. H is Planck constant. If it is correct, you can tick it. If modification required, make the modification with a different color. Give me the second one. Give me the second one. F equals Y A X divide by L. Second equation I gave. There F is force. F is force. Force equal to dimensions of force M L T minus 2. A cross sectional area. I would say cross section, otherwise area. True, it is cross sectional area. Say area easy. Area dimensions L squared. X extension. Extension. Extension means, of course, here the story, you apply a force. When you apply the force, distance will be more, length will be more, and that amount of increment is the one we call extension. Our x dimension, again length. L original length. Again L dimension will be capital L. I will subject y. Y is equal to FL. Send this here, FL divide by AX. AX. Y dimensions equal FL divided by AX dimensions. Again, F dimensions, L dimensions, A dimensions, X dimensions. Now let me to substitute. F ml t minus 2 length L cross sectional area L squared. This is L again. So this L square cancels off. So what is left? M L to the power minus 1 t to the power minus 2 ml minus 1 t minus 2. What is the next equation I have given? U divided by D. Next I have given F equal, son, this is, what is the word, son? Neta. N and a tail, neta. N and a tail, neta. A U divided by D. Did I tell you delta U divided by delta L or U? Velocity different, delta L. Delta X. Delta X. It's same letters I have read. Right. Here also I forgot, son. Why I should say what it is. Y Young's modulus. Young. Young's modulus. Here F is force. Force will be ml t minus 2. A surface area. Our area. A dimensions L squared. Delta U velocity difference. Velocity difference dimension will be same as velocity. Do you take a difference? Still same as velocity. Delta X distance or otherwise height gap. Height. Our delta X dimension again L. Neta. Coefficient of viscosity. Coefficient of viscosity. So it is like how easily the particular liquid flowing. This is for liquids. This is for liquids. Now if you take water and start pouring, and you will see a difference if you start pouring honey. It will be coming like a small thread. That is because of viscosity difference. It is due to the viscosity difference. The viscosity of honey will be high. Now let me do subject this neta, coefficient of viscosity, F delta L, F delta X divide by A delta U. Our neta dimensions is equal to f delta x divided by a delta u dimensions, same as f dimensions delta x dimensions a dimensions u dimensions. F is force m l t minus 2. I do keep on substituting. Delta x length L. A surface area L squared. L squared. U LT minus 1. LT minus 1. Again, this L squared cancels off. M. This L will be going up. L minus 1. One of the T get cancels off. T minus 1. ML minus 1. T minus 1. Right, next equation I have given V divided by T, because this is Poisson's equation, pi divided by 8 neta r to the power 4 p divided by L. Did I say delta p divided by delta L? Doesn't matter. Right. Only delta p. No L anywhere. Sure. Delta. Right. That's okay. Right. So here I have not written delta, doesn't matter, right? Delta p pressure. Of course, this is pressure difference divided by the length. That's all right. So here V volume. V dimensions L to the power 3. T is time. T dimensions capital T. R is radius. R dimensions L. Delta P pressure difference. Pressure difference. Then delta P dimensions. So do you remember delta P pressure dimensions? M pressure dimensions M L minus 1 T minus 2. Good. L again length. I will subject neta equal pi divided by 8 V L T r to the power 4 delta P. Therefore, dimensions of neta is equal pi divided by 8 dimensions, because no dimension for that. T dimensions r to the power 4 dimensions delta P dimensions V dimensions L dimensions. Therefore, neta dimensions equal to, let me to substitute one by one, T capital T. R to the power 4 L to the power 4 delta P M L minus 1 T minus 2 V L to the power 3. Here again L. M remains. These two cancels off with that. L minus 1. These two again. T minus 1. ML minus 1. T minus 1. We got earlier. It is the same. Whatever the formula you use, if it is the same thing, you need to get the same. You need to get the same answer. Therefore, particular dimension will not depend on the equation you select. You can select any equation, neta, whatever the equation, if neta is there, coefficient of viscosity is available, you will be getting same answer. Therefore, by selecting, you don't have to waste your energy. Take any equation. If you know others, yes, job can be done. What is the next I have given? Next, maybe fourth one or fifth one. F equal 6 pi neta RU. This is how I wrote. Right. F again force. Force. Therefore, dimensions of F ml t minus 2. R radius. Radius. Radius is equal to the dimensions with dimensions of radius L. U velocity. Velocity. U dimensions equal LT minus 1. LT minus 1. Now, I will subject the neta is equal to F divided by 6 pi RU. Therefore, neta dimensions F divided by 6 pi RU dimensions. F dimensions 6 pi dimensions, R dimensions, U dimensions. Now I will substitute dimensions of neta equal F ml t minus 2. 6 pi no dimension. Here R L dimension U LT minus 2. One of the L get cancels off. M will remain. L going up, L to the power minus 1. T minus 1 and T minus 2 cancels off. Only T minus 1 will remain. That is theta. Right. Same. What is the next formula I gave? That's all. Okay, good. You want more formulas? Another formula. This is terminal velocity V equal 2a squared rho minus sigma g divided by 9 neta. Terminal velocity V 2a squared rho minus sigma into g divided by 9 neta. Alright. What is V? Velocity. LT minus 1. A radius. A radius. Shall I say R then? R. R. Radius. Radius R. It is L. It is L. Rho, density of solid density. Rho dimensions, density dimensions. Remember? What is the dimension of density? M L minus 3. Sigma dimensions. Liquid density. Liquid density. Again it is density. ml minus 3. G acceleration due to gravity. Gravitational acceleration. Gravitational acceleration. Then G dimensions. Acceleration LT minus 2. LT minus 2. Neta, coefficient of viscosity. That is the one I need again. Coefficient of viscosity. So it is like this. I know you all are very much talented students. There is no doubt. But you can't skip my lines. What I have written there, those steps is a must. Therefore, remember especially when you do A level, so you should adhere to one thing. There will be certain number of lines you want to show. In case though you get the answer, if you skip the line that we are paying, you will be losing the mark. And that is why we are supposed to follow the scheme, and that is why you are to monitor the scheme where we are paid. That means to which steps that you are getting marks. Right? Therefore my request, son, follow me what I am writing on the board, because I will be skipping all possible lines. If I am writing something to explain, still I will be telling I am writing this to explain. Therefore those lines even which that is not required, they are not compulsory, but other lines compulsory. I will be coming, and when I see some mistake I am showing you, just not to put you into trouble, because you are supposed to learn. Therefore I will be telling if I see the mistakes. Right. Let me to write this. Neta would be subjected. Straight away you can subject, and that one no problem. One line, one shot. Neta would be equal to 2r squared rho minus sigma g divided by 9v. V is velocity here. Therefore dimensions of this equal to 2r squared rho minus sigma g 9v dimensions equal 2 divided by 9. Straight away I will write r squared dimensions. So for this I will write the dimensions straight away. Rho minus sigma dimensions and g dimensions divided by v dimensions. 2 divided by 9, no dimensions. R L to the power 2. So there I need to ask a question. So if you add 2 mango mangoes and 5 apple. 2 mangoes and 5 apple. What is the answer? Two mangoes and 5 apple. I want you to add. You can say 7 apple, can't, right? 7 mangoes also wrong. You can say 7 mango apple also wrong, no? Because I took only 2 apple and 5 mango. Oh, 2 mangoes and 5 apple. So it is a different thing. You should cut them all and put it to one thing. One thing it will be a salad. It is a different thing, right? But I didn't ask you to cut, right? Right. So here, what I want to tell you, son, addition, subtraction can be done only if they are the same. If it is the same only, you can do this. Same dimensions material can be added. Same dimension material can be subtracted. But different can't. But on multiplication, no such a thing. Multiplication you can do any. Division you can do any. Here, rho minus sigma can be processed because both are densities. Both are density. Therefore, when you take the dimension, when you subtract, don't misunderstand, dimension does not get subtracted, right? Dimension will be left, but it is the same of 1. Even the gap of material, when you subtract, it will be the same dimension. Therefore, it is equal to the rho dimension as well as sigma dimension. Rho minus sigma dimensions will be, because it is the same, you can subtract, yes. Even subtracted result will be having the same dimensions. ml minus 3. G acceleration due to gravity, L t minus 2. V velocity, L t minus 1. M will remain. L squared, L and L to the power 3 cancels off. This will be sent up. Therefore, L to the power minus 1. These two getting cancels. T to the power minus 1 will remain. So that is the final answer. Am I supposed to explain this again? Son, I had this one together straight away, rho minus sigma. Therefore, so subtracting places, even addition places, you can write the dimension of 1. It is the dimension. This density ml minus 3. For the whole term taken there. You don't have to write the dimension here separately, the dimension there separately. You don't have to write. It is the same dimension of 1 would be coming. Right, next one. So when you have, see, this is very interesting. You have a mass m1, there will be another mass m2. In between masses there are attractive forces. Who says? Newton says. Newton found. When he found Newton's gravitational law, and he gave that force F is equal to capital G m1 m2 divided by r squared. R is this distance. We will be studying later. And that means even between you and me there will be forces. The magnitude is this much. Magnitude is this much. Therefore, say in air, if there is a possibility to keep two masses, due to that attractive forces, they will be coming and colliding each other. That happens. Right? Newton found this. G is called universal gravitational constant. Universal gravitational constant. That means he says this particular force, right? Universal means, so whether you are inside water, whether you are inside glass, it is the same. Universal means that will not depend on the medium. Inside air, inside water, inside glass, still you will be getting the same force. Right? That is why we call universal gravitational constant. Now F is force, F dimension, ml t minus 2, m1 mass, m1 dimension capital M, m2 also mass, the other mass, that is m, r distance, L. Right, I want you to find the dimension of universal gravitational constant. Universal gravitational constant. Let me to subject this. G equal FR squared divided by M1 M2. Therefore G dimensions will be equal to FR squared M1 M2 dimensions, which is equal to F dimensions, R squared dimensions, M1 dimensions and M2 dimensions. Then G dimensions equal F MLT minus 2 R squared L squared. This is capital M. Here again capital M. L to the power 3, T to the power minus 2, M to the power minus 2. L to the power 3, L to the power minus 1, because 1 M is there, minus 1, L to the power 3, correct, T to the power yes, here M, there M cancels off, M minus 1. I will give another equation. So this is V equal square root 2 G capital M divided by R. Let me to tell you this story. So have you heard there were some set of people who has thrown stone to the moon, thinking that the stone will to the moon, part of the moon will be climbing down, that will land to the ground and they can eat a piece of that. Have you heard such a story? Right? What do you think, son? Can you throw any stone in such a way that will be hit into the moon? Can or can't? Son, in physics we learn, yes we can. We can. Son, this is the particular velocity you have to throw the stone. If you throw the stone with that particular velocity calculated to capital G capital M divided by R square root, and that will be going and hit into the moon. Whether the portion of moon will be coming here or not, that is a different thing, right? Anyhow, that will be going. That is called escape velocity. This is called escape velocity. Later with gravitational fields we will be studying. If you want to take anything out of our gravity, this is the velocity to be given at the ground. This velocity to be given. Right. Using this, calculate G again. I should tell what these terms are. V is velocity. Lt minus 1. Ms, that is capital M. R radius. Same as L radius. G, as I defined earlier, universal gravitational constant. I can write, having subjected this, first square that. I will take 2 steps. If you can do one shot, yes, no problem. But I will use 2 steps. V squared equal 2gm divided by r. Then take G. Will be equal to V squared r divided by 2m. Therefore, dimensions of G equal V squared r 2m dimensions, which is equal to V squared dimensions, R dimensions, 2 dimensions, M dimensions. V squared Lt minus 1 squared R L, 2 no dimensions, this is M. L squared with this L. This step also not compulsory. I squared this. You can write now L to the power 3, T to the minus 2, M minus 1. So one more equation. When you have 2 charges, here Q1, there Q2, still there will be a force. Distance r apart. That force is F. Can be written as Q1 Q2 divided by 4 pi epsilon. This is called epsilon. R squared. We'll see what are they. F force. Dimensions mlt minus 2. R distance. R dimensions will be L. Q1 charge. Dimensions of Q1. So what is the dimensions of charge? IT, current and the time. Q2, again charge. Q2 dimensions, IT. I need epsilon permittivity. What is it? Permittivity. Permittivity. Permittivity constant. Now subject permittivity. Q1 Q2 divide by 4 pi Fr squared. Permittivity dimensions equal Q1 Q2 4 pi Fr squared dimensions equal Q1 dimensions, Q2 dimensions, 4 pi dimensions, f dimensions, r squared dimensions. Permittivity dimensions. Q1 IT, Q2 IT, 4 pi no dimensions, f ml t minus 2, r l squared, I squared, t, this 2 squared and this is going up, power 4, L to the power minus 3, M to the power minus 1. Next, so of course this is called electric constant, permittivity electric constant. Now I am going to give you magnetic constant. It is called permeability. This story, you have two current carrying conductors, I1, I2. Shall I say I1, capital I1, I2. Distance x apart. Still there will be a force of F on each other. I will take a length of simple L. On that length portion, that is the force I have marked. So that force can be right again, force, that is magnetic force, equal mu I1 I2 L divided by 2 pi R, R is x. That is the formula. F is force, ml t minus 2. I1 current, capital I. I2 current. So no need to learn these equations by heart, right? Because we will be studying later. I am just calculating dimensions using having subjected the formula. Length L, it is capital L, x, the distance between these two, mu permeability, permeability. The other one, permittivity. I need to subject this mu. Two pi LF I1 I2 L. Dimensions of mu 2 pi LF I1 I2 L. 2 pi dimensions, L dimensions, F dimensions, I1 dimensions, I2 dimensions, L dimensions. Son, wait, where is my X? 2 pi XF. 2 pi XF. xf. Two pi non-dimensions x, l, f, ml t minus 2, I1, I2, I. This is L. LL get cancels off. LL cancels off. M 1L will be remaining. T minus 2, I minus 2. So now I want you to simplify this. Can you find the dimensions of this? Square root 1 divided by mu epsilon. Calculate dimensions. Calculate this. Right. 1 over mu epsilon square root dimensions. Square root to be taken. I need a square root. So I need to calculate 1 divided by mu epsilon square root the dimension of this equal 1 divided by dimensions of mu dimensions of epsilon I'm sending the dimension out and I suppose to take the square root 1 divided by dimensions of mu this ml t minus 2 I minus 2 epsilon here I squared t to the power 4 I squared t to the power 4 L minus 3 m minus 1. Again I should take the square root 1 divided by m get cancels off L minus 2 t plus 2 I get cancels off square root. So this can be taken up L squared t minus 2. I took this up. When this is taken up plus taken up minus. Now square root. Square root mean to the power half. Here half L. There half t minus 1. LT minus 1 is the unit of what? Velocity. Velocity. Son, mind you, we are having an equation. I will write here or there. We are having an equation. Velocity of electromagnetic wave C. We call C the velocity of electromagnetic wave, sunlight. Now that C is equal to square root 1 divided by mu epsilon. That is why we are getting, when you simplify everything, it is LT minus 1, it is velocity. The velocity of this light rays will be changing from medium to medium. Why? Permeability and permittivity will be changing. I hope you have heard electromagnetic ray is a combination of electric field and the magnetic field. The electric field and the magnetic field from time to time will be varying and it is perpendicular to each other. The while it is proceeding, even in this medium, when electromagnetic rays proceeding, electric field and the magnetic field will be going in the area, in this space. That is why the velocity is connected to those two constants. Never mind, just your knowledge. I am putting little by little your knowledge, but this is our lesson. Later we will be studying, right? Therefore, physics become very interesting, son, because that is the one we are going to study. So lastly, I have given one question to calculate the thickness of paper bundle. Yes, you calculated. Now let me to remind you what I said. This is a paper, right? That is a paper. Thickness of this paper 0.5 millimeter, right? That is how I gave 0.5 millimeter. Now I will be folding this one time, second time, third time, fourth time. Likewise, how many times I folded? 50 times. 50 times folded. Now what is the thickness of paper bundle? 1 paper thickness. .5 millimeter. Folded 50 times. Folded 50 times. Did you bring the answers? You can show me. But you showed me the answer, right? Sir. Yes, yes. 50 times. Not that. Not that. 2 to the power 49 millimeters. How much is that? Yes, one has done. Very correct. To simplify it correct, right? Yes. If it is simplified correct, let me to put into the board final answer. I will explain how it is to be done. Five 6 2 9 4 9 9 5 3 4 2 1 is that the answer? See, so very easily you can climb definitely to the moon. When you climb on this, you will be at moon. Let me show you rough calculation. Right. Now let me show you. So here only one leaf. When you divide into 2, how many leaves? 2. Now how many? 4. Now how many? 8. Now 16. Understand, each time when I fold it, the amount will be double. Now I have folded how many times? 50 times. Therefore, each time I fold it, it will be doubling. I had only one. Now, each time when I fold, it will be doubling. But how many times I am Doubling this 50 times. Now this much of papers are available now. First 1, 2, 4, 8, 16. That is how that increases, right? First 1, 2, 4, 8, 16, 32. That is how that goes. See how many times I have folded here. 1, first time, second time, third time, fourth time, fifth. Only 5 times. Here 50 times. One paper thickness is 0.5. Therefore you have to multiply with 0.5 millimeter. Therefore that is the answer. 2 to the power 50 into 0.5 millimeter. I will take 1, 2 out, right? Therefore 2 into 2 to the power 49 into 0.5. These two will be 1. 1 into 10 to the power, 2 to the power 49 millimeters. Then I wanted you to simplify this. So can you tell me 2 to the power 10 how much? 1024. So if you take like this, even shall I go with this 2 to the power 10? I will start from the beginning. Thickness will be equal to that number. 2 to the power 50 into 0.5, unit is millimeter. Therefore 2 to the power 10 plus 10 plus 10 plus 10. 1, 2, 3, 4 plus 10 into 0.5 millimeter. Why I separated you will understand. 2 to the power 10 into 2 to the power 10 into 2 to the power 10, 2 to the power 10, 1, 2, 3, 4 into 2 to the power 10 into 0.5 millimeter. So each 2 to the power 10, 1024. One, two, three, four, 5. That I will write 1.024 to the power 5 into 10 to the power 3 into 5 into 0.5 millimeters, right? 1.024 to the power 5 will be almost equal to 1 plus 0.024 into 5. That magic simplification, right? 10 to the power 15, that is this, into 10 to the power 0.5 millimeters. That is simple, sir. 1, when you multiply this 5, 1 to 0.12. That's not that answer. No. You have to divide this by 2, no? Yes, it is correct. Into 10 to the power 15 into 0.5 millimeter. I will multiply these two. 0.56 into 10 to the power 15 millimeters. I will take 1 here. 5.6 into 10 to the power 14 millimeters. 5.6 millimeter 10 to the power minus 3, right? 10 to the power minus 3. 14 minus 3 meters. 5.6 Simplify. Milli mean 10 to the power minus 3. I substituted that. And here 10 to the power 11 meters. 10 to the power 11 meters. Then nearest number, it will be giga, but 10 to the power 9. 10 to the power 9 gigameters. 5.6 into 10 to the power 2 into 10 to the power 9 meter. 560. This is gigameter. See one leaf, how long you can go? Keep on folding. Right? Keep on folding. Right. Copy this simplification. Check whether that is correct. 1, 2, 1, 2, 3, 4. Yes. So that very good. This is correct, right? Very good. The student calculation will be very correct. I did rough calculations, right? Because I am not getting these decimal places. No, I am getting only 5.6. Right? That is this point, right? What I did, son. Even later I will be teaching. When you have 1 point something to get any power, if this number is very much small compared to the number in front, then you can neglect. It's supposed to be 1, right? It's supposed to be 1. If it is 1, you can write 1 plus this number into the power here. This plus, because this can be written as 1 plus 0.024 to the power 5. Right? That is the number requires. This can be processed like this. Can be taken in. But don't worry, later I will be having the time to teach you. Just to do the sum I did that simplification. Otherwise you can use the logbook. Right? Your method will be the CER's book, no? Grandfather's book, logbook. So if possible, now I would ask you to bring such questions. I would like to simplify. Now I am giving question for you now. If possible, find such questions and bring. Copy the answer. Now today, I will give one more question. This is a circle. Easy question, right? That is easy. So the radius of this R, radius of that R, at a distance A, I have drawn this line perpendicular to that. Distance A. Right, that is a circle. At a distance A, I have drawn this perpendicular. I need to calculate this area. How much is that area? You can use A and R. You can keep A and R. So let me give you one more question. Listen to me carefully. I am telling a story because this is two exercises. One thing, if you do physically, it will be an exercise for your brain as well as for your hands. Right? We'll see what I am telling. So this is fixed. For that one. And you get circles. Few circle. At the center, in each one, 1, 2, 3, 4, 5, there will be a whole set. Now I do insert one by one, that is the largest, second largest, third largest, fourth largest, last one. Right? So these are the conditions. I need to bring all 5 finally to this one. Same order. I need to set in such a way, 1 largest, second large, third large, fourth large, fifth one, like this. Right? The middle one you can utilize, doesn't matter. A, B, C, you can utilize. If you want, you can use. Even inside that you can insert. But only thing, you can raise only one at a time. You can't take the other one to the hand until you keep somewhere. Either B, C, E, somewhere you have to keep. Right? You can raise only one at a time. Always smaller one should be on top of a larger one. You can't interchange. That means you can't keep larger one on top of a smaller one. Right? Therefore you can't keep like this. The middle one, the one which is inside will be closed then. You can't do like that. Always larger one, smaller one should be on top of the large one. Smaller one should be on top of large one. You can't keep other way around. That means you can't keep smaller one and then a large one. Smaller one will be closed then. No, you can't keep like that. Right? And tell me now how to set everything there. Copy this. This can be done. If you bring, I will show you how it is to be done. If you fix these 3 and 5 circles, that can be done. Can do. If you have any question, we can ask the process. Understand how to do? Son, do you think how much of time will be taken to do this? Can't. Tell me how you do. Few steps. Tell me. Son, of course, one explain how to do. The method is correct. Even I will tell you, son. Son, if such 20 knots of plates are given, we need 3 generations to complete. That means if you start keep on doing, he will be getting older. The next person supposed to come, keep on doing, he will be getting older. That means generally at least 100 years will be taken to do this. Doing full time this exercise, 100 years will be taken if you get 20 plates. But that can be done. For 5 it will take a certain time, right? But the work can be done. So these days, of course, this will be a very good exercise if you could do, because you can take just 5 plates and keep in 3 rows, right? You are changing here and there. Check whether you can do this one. Very good exercise for your brain as well as for your hand, because you will have to think and do, think and do. Very good exercise. But this can be done. Right, let me to go for next. Anyone want to check your answer? Yes, I will check. Oh, yes, no mind, yes. Right. Right, correct. Right. Yes. 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 Correct. That is the procedure. But you will have to repeat in each. You will have to repeat the process, everything from the beginning. So we took first usage of unit and dimensions. Let me to take the second one, second usage, to check whether the equations are dimensionally correct. That is the second usage. I am going back to the lesson. To check whether equations are dimensionally correct. So under that, let me to write some properties. Right? Properties. Properties of equations and dimensions. Under that, I supposed to give you the properties first. Properties of equations and the dimensions. First one, in an equation, left hand side dimension should be same as right hand side dimensions. In an equation, left hand side dimensions would be same as right hand side dimensions. Next, addition and subtraction can be done. Addition and subtraction can be done. Addition and subtraction can be done only with equal dimension quantities. Equal dimensional quantities. If constants are having dimensions, if the constants are having dimensions, they are to be considered in the equation. Next step, non-dimensional quantities in the equation cannot be verified using dimensional analysis, otherwise you can say dimensional equation, using dimensional equation. Right. That cannot be, right? Now that also property. Let me to tell you. So remember we wrote F equal 6 pi neta RU. This is how we wrote. But with the dimensions, I can check whether it is R or R squared or U. That one I can check. But whether it is 3 pi or 2 pi or 6 pi, I cannot compare. Because they are not having dimensions. Therefore, any non-dimensional quantity I cannot check. I can check only these dimensional quantities. For this, no dimension. Therefore, if someone write 2 pi, still I will be getting same answer. And that is the story we are telling. Non-dimensional quantities we cannot check. I will start with a simple one. Now we are going to do the exercise, right? First, so I will give this S equal ut plus half at squared. That equation I am going to say dimensionally correct, right? To prove dimensionally correct, this term and that term need to have same dimensions. Again, when I simplify the dimensions of this, it should be same as that side. Why? These two are the same. Left hand side it will be this. Should be same as right hand side, the other one. I will tell you what these are and I will do one example. S is displacement. S is displacement. Then dimension of S, L. U, initial velocity. Initial velocity. Therefore, dimensions of U, LT minus 1. T time. No need to have bracket. T time. T dimensions, capital T. A, acceleration. Acceleration. Therefore, A dimensions, LT minus 2. LT minus 2. Now what I am going to do, I will find the dimensions of this. Half a t squared dimensions. It is equal to half dimensions, a dimensions, t squared dimensions. Again, I know whether this is half or 2 or 1/3, I can't check. Right? That will not be checked in this process. Half no dimensions. A, LT minus 2. T squared, simple T squared, dimension T squared. Now this is equal to, when you simplify, it will be L. Again, I will take this term. UT dimensions. I took next term. It is equal to U dimensions and T dimensions. U, LT minus 1. T, capital T. When I add these two or simplify, it is L. Again, take the left hand side, S. Dimension L. Can you see I am getting all the same? All the same. Therefore, I can write dimensions of S same as dimensions of UT, same as dimensions of AT squared. So after that I can write, because I have shown that, then I can write this. After that I can say This equation is dimensionally correct. It is dimensionally correct. Right? Why we use the letter dimensionally? I have not checked whether this half is exactly correct, because non-dimensional quantities are there. That I have not checked. Even 1/3 you will be getting same dimensions. Right? Even 1/4 same dimensions. Now we call it is dimensionally correct. Given equation is dimensionally correct. I will give you another one. After copying this, you can try this. V squared equal U square plus 2AS. Check whether this is dimensionally correct. Yes, 2AS. 2AS. So V term I have not written, it is the final velocity. Others I have written. V again final velocity. Velocity dimension again LT minus 1. U will be same as this, A also same as here, S also same as there. Therefore I will use those. 2AS dimensions equal 2 dimensions, A dimensions and S dimensions. 2 no dimension, A LT minus 2 into L squared T minus 2. U squared dimensions LT minus 1 square L squared T minus 2. V square V again LT minus 1, that square L squared T minus 2. Can you see here L squared T minus 2, there L squared T minus 2, here also L squared T minus 2. Therefore 2AS dimensions will be same as U squared dimensions, will be same as V squared dimensions. That is the requirement. See, I am adding these two. If I am adding, I need to have same dimensions. Yes, you can add. And the left hand side dimension should be same as right hand side dimension. That also correct. Why V squared dimensions will be same as the dimension of this. Right? Therefore, this is dimensionally correct. Equation is dimensionally correct. Equation is dimensionally correct. Check whether this is correct. S equal U plus V divide by 2 into T. Same terms. U initial velocity, V final velocity, time is T, S is displacement. So there, one thing, as we are adding these two, we have two ways of checking. First, you can check whether these two are having the same dimensions. If so, you can add it. Therefore, before one method, without expanding the equation, you try as it is, without expanding this. For that, you should show dimensions of U same as dimensions of V. Therefore, check those two. We know it is the same. U initial velocity LT minus 1, V again LT minus 1. The dimension of this will be same as that. No problem, you can add. Right? Then better say dimensions of U equal dimensions of V. Adding, no problem. Now calculate the dimension of whole term. u plus v divided by 2 into t dimensions equal u plus v dimensions, 2 dimensions and t dimensions. U dimension will be same as u plus v dimension because we have shown it is the same. Lt minus 1. T, capital T, 2 no dimensions. Now it is L. Take the left hand side. Dimensions of S will be same as L. Now I am getting S dimensions will be same as u plus v divided by 2 into t dimensions. Therefore, now it is dimensionally correct. We say it is dimensionally correct. Me to give you few more equations to check. X equal R sin omega t. You have to check whether this is dimensionally correct. X is distance. X dimension will be L. R radius. R dimension will be L. Omega angular velocity. Omega dimensions t minus 1. T time. T time. T dimensions will be t. X equal R sin two pi t divided by capital T minus x divided by lambda. Y displacement, distance say, R radius, T time, capital T time period, T dimensions also T. X displacement. Lambda wavelength. That also L. in amount of substance. N naught lambda decay constant. T lambda t, simple t. Capital T. Now how to check this? So for such an equation, you should check. So this sine values can be taken for angles. Sine values, cos values, tan values can be taken only for angles. Now if it is being an angle, what would have been the dimension of inside? No dimensions. Now this product should not give any dimension. If any dimension left, then you can't take the sine values. If any sine values, cos value, tan value given, you should show inside no dimension. Again, this left hand side dimensions and the right hand side dimensions will be the same. So here it is the same technique, right? Same technique. That is what you have to show. Even you can make a note. If you are having sine values, cos values or tan value, the angle should not have any dimensions. The angle should not have any dimensions. That was a property, right? That should be a property. Now that will be the same here also. That will be the same here. For the angle we said no dimensions inside. So can you tell me what will be the answer if you take 10 to the power 2 meter? 10 to the power 2 meter. What will be the answer? So you can take powers only numbers. You cannot take powers of units. You can't take 10 to the power meter, no answer. 10 to the power kg, no answer. Whatever the number here, right? Therefore, the dimensions you can't have as in the power. Here you can't have any power. Right? You can't have the dimension in the power place. Therefore, here I have written e to the power something. Therefore, that portion you should not have any dimensions. When you write the equation, whatever, how much that power being large, no dimension inside. Only for the numbers you can take powers. Right? You can write any power should only be with a number. Should only be with a number. But no dimensions. No dimensions. So here then very simple. What you have to do? You should check what is the dimensions of omega t. It is omega dimensions, t dimensions. omega dimension t to the power minus 1. T to the t dimension t. Therefore 1. No dimensions. So that portion is alright. That portion is alright. Then r sin omega t dimensions. R sin omega t dimensions equal r dimensions sin omega t dimensions. So whatever the value here, no dimensions. Because sin values, cos values, tan values, no dimensions. So this is equal to L only. Here no dimensions. That is L. Then x dimensions will be, it is distance, that also equal to L. Therefore I can write x dimensions will be same as r sin omega t dimensions. Therefore this is dimensionally correct. That is dimensionally correct. Right. So these two I will leave at home, but what you have to show, dimension of this, dimension of that, no dimensions. Because when you subtract again, no dimensions. No dimensions. Because 2 pi also with no dimensions. You show that part, and again this dimension will be same as automatically to the r dimension, because this whole portion will not be having any dimensions. No dimensions. Just copy this. I will be putting the answer next week for these two. Therefore here, in addition to the learning part of our equation to check whether they are correct, we are learning some properties in equations. Right? When you add, when you subtract, they will be with same dimensions. So next week we will be starting another very important part. It is, we are going to develop equations. We use the dimension, that is the third usage. We are going to develop equations, that is with a certain procedures, and we have a little longer procedure, and little by little we can develop them.